Hi there, Mr. Holcomb here with another episode of The Math Behind the Modules. This is Lesson 13, Changing Scales. Okay, classwork opening exercise. We're given this ratio, scale factor is length in scale drawing divided by corresponding length in the original drawing. Describe using percentages the difference between a reduction and an enlargement. Okay, so pause the video, see if you can answer that, and then I will bring in the answer. Okay, so a scale drawing is a reduction of the original drawing where the lengths of the scale drawing are smaller than the lengths of the original drawing. The scale factor will be less than 100%. A scale drawing is an enlargement of the original drawing when the lengths of the scale drawing are greater than the lengths of the original. The scale factor, therefore, will be greater than 100%. Okay, so now it says use the two drawings below to complete the chart on the next page. Calculate the first row, drawing 1 to drawing 2 only. Okay, so calculate the first row, drawing 1 to drawing 2 only. Okay, so I didn't have to go back and forth. I just copied it over to this page here. Okay, so drawing 1 to drawing 2. Drawing 1 to drawing 2. Quotient of corresponding horizontal distance. Horizontal distance is right here, and horizontal distance is right here. Drawing 1 to drawing 2. So it's getting larger, right? We're going this way. That's what this 2 says. We're scaling from drawing 1 to drawing 2. It's an enlargement, so it has to be greater than 100%, and therefore the numerator has to be bigger. So I'm going to put the 3.92 in the numerator and 2.45 in the denominator. And when I calculate that in my calculator, it comes out to be 1.6. Now it says quotient of corresponding vertical distances. So here's the vertical distance compared to this vertical distance. Again, we're going from 1 to 2. 100% increase means the numerator is bigger. So the 2.4 is the numerator, and the denominator is 1.5. And when I calculate that, that also comes out to be 1.6. Now we want to represent the scale factor as a percent. So 1.6, if we move the decimal 2 places to the right, is 160%. Reduction or enlargement, it's more than 100%. It is an enlargement. Okay, so they said to only calculate the first one, so that's all I'm going to do. So now I'll delete this and clean this up and move on. Okay, now it says compare drawing 2 to drawing 1. Using the completed work in the first row, make a conjecture statement about what the second row of the chart will be. Justify your conjecture without computing the second row. Okay, so here's what you should have had, something similar to this. Drawing 1 will be a reduction of drawing 2. I know this because the corresponding lengths in drawing 1 are smaller than the corresponding lengths in drawing 2. Therefore, the scale factor from drawing 2 to 1 would be less than 100%. Now it says to compute the second row of the chart. So it's the same values. So I'm not even going to look at the drawing anymore. I'll just use the values I used above. So now I'm going from 2 to 1. All I'm going to do is take the reciprocal. I'm going in the opposite direction. I'm going from the 2.45 here, or 3.92 inches back this way. So my denominator, or my numerator, has to be smaller than my denominator. So 2.45 over 3.92. And when I calculate that, what is that calculation? Okay, this comes out to be 0.625. Okay, and then I'm going to calculate this one, let me change colors. Now I will calculate the vertical distance, 2.4 to 1.5, so 1.5 over 2.4, and that's also going to come out to be 0.625. Scale factor as a percent, just move the decimal 2 places to the right, 62.5%, and that is a reduction. Okay, now it says to compute the second row of the chart, was your conjecture proven true? Explain how you know. Okay, so the conjecture was true because the calculated scale factor from drawing 2 to drawing 1 was 62.5%. Since the scale factor is less than 100%, the scale drawing is indeed a reduction. Example 1. The scale factor from drawing 1 to drawing 2 is 60%. Find the scale factor from drawing 2 to drawing 1 and explain your reasoning. Okay, so if I go this way and it's 60%, that is 60 over 100 as a fraction. If I'm going to go back the other way, this way, and I'm going to scale from 2 to 1, then I take the reciprocal of that and I call that 100 over 60, or 10 over 6, and then when I calculate that, then I go 6, 40, 6 times 6 is 36, and it's repeating. So it's going to be 1.67%. You move the decimal 2 places to the right. Okay, so that is going to equal 166%. There's a dot here that's bugging me. 100 is 166 point, and I don't want to use a decimal because it goes on forever and ever. 0.6 repeating is 2/3. 166 2/3%. Okay, scale factor of drawing 1 to 2. Explain your reasoning. Okay, so the reason is the scale drawing from drawing 2 to drawing 1 is an enlargement. Drawing 1 is represented by 100%, and drawing 2 is a reduction of drawing 1 is represented by 60%. A length in drawing 2 is the whole, so the scale factor from 2 to 1 in the length in drawing 1 equals percent times length in drawing 2. Example 2. A regular octagon is an 8-sided polygon with side lengths that are equal. Okay. So in geometry, you will learn that regular means all the sides are equal. A regular octagon, equal length sides. All 3 octagons are scale drawings of each other. Use the chart and the side lengths to compute each scale factor as a percent. How can we check our answers? Okay, so we have actual drawing to scale drawing, drawing 1 to drawing 2. So we are going from here to here. I know that's an enlargement, so it's going to be greater than 100%. The scale factor, so we're going to say quantity equals percent times whole. So length of drawing 2 is going to be my quantity equals percent, and I'll represent that as P, times the length of drawing 1, which is 10. When I solve this for P, I divide both sides by 10. So therefore, P equals 10 goes into 12 once, and 10 goes into 20 2 times, so it's 1.2. Converting that to a percent, move the decimal 2 places to the right, and that is 120%. Equation to illustrate relationship is 10 times 1.2 equals 12. Okay, So now we're going to do drawing 1 to drawing 3. Well, we're going from 10 to 8. That's a reduction because that's less than 100%. We are decreasing in size. If we use the same equation, Q equals percent times whole. So we're going to take the length of drawing 3, the one we're going to, and that is 8, equals some percent times the whole that it was, which is 10. And solving for P, we divide by 10. These cancel, and P equals 8 divided by 10, or 0.8. If I move the decimal 2 places to the right, that is an 80% reduction. And my equation is going to be 10 times 0.80 equals 8. Or 10 times 0.8 equals 8. Okay, drawing 2 to drawing 1. So now on this one, we are going this direction. 2 to 1. So our quantity equals percent times whole. And our quantities have always been the numbers that we are going to. So there's my Q, 10. Percent times the whole where we came from, which is 12. Divide both sides by 12. And I get P equals, let me scroll a little here, 10 divided by 12, which reduces to 5 over 6, which is 0.83 repeating when you put it in your calculator. So that is 83 1/3% reduction. So I take 12 and I multiply by 0.83 with the repeating 3, and that is going to equal 10. Okay, so on the next page we are continuing with the same diagram. So I copied it over to this page, and now it's saying to go from drawing 2 to drawing 3. So that's less than 100%. So it's a reduction. We should have an answer less than 100%. So we write quantity equals percent times whole. And my quantity is always the length in the drawing that we're coming from, if you go back and look. Drawing 1 to drawing 2, but what we were going to was our Q. So that is 8 equals some P times what we came from, which was 12. Divide both sides by 12. And P equals, well, 4 goes into 8 twice, and 4 goes into 12 3 times, so it's 2/3, and that is 67 2/3%. So my equation is going to be 12, my whole, times my percent, equals my quantity. Okay, and let's write that up there. Whole times percent equals quantity. All we're doing is writing this. We just flipped it around. We just put the Q on this side and the P and the W on the other side. Okay, next one. Drawing 3 to drawing 1. So now I'm going from this 8 to this 10. So it's an enlargement because it's greater than 100%. So Q equals P times W, and the Q is what we're going to, 10, equals P times 8. Divide both sides by 8, and P equals 8 goes into 10 once with a remainder of 2. 8 goes into 22 times with a remainder of 4. And 8 goes into 40 with a remainder of 5. So that, with the decimal move 2 places to the right, is 125% enlargement. My equation is going to be my W times my P equals my Q. I'm sorry, equals my W. Now I had that right. My W goes here. W in this case is 8, and it equals my Q 10. There, that's better. Okay. And now we're going from drawing 3 to drawing 2. So now we're going to go from here to here. So Q equals percent times whole. And the quantity in this case is going to be 12 equals P times 8. Divide both sides by 8. And we get P equals, well, it's just the reciprocal of this one up here, so it's 3/2. So that is 150%. So then I write my W, 8, times my P, which was 3/2 or 1.5, and that equals my Q. Okay, example 3 says the scale factor from drawing 1 to drawing 2 is 112%. And the scale factor from drawing 1 to drawing 3 is 84%. Drawing 2 is also a scale drawing of drawing 3. Okay, so some unknown. Is drawing 2 a reduction or enlargement of drawing 3? Is drawing 2 a reduction or enlargement? And the answer is, it's an enlargement. And justify your answers. Okay, so we first need to find the scale factor of drawing 3 to drawing 2. We want to find that scale factor. So we're going to use quantity equals percent times the whole. And drawing 3 is the whole. So this is our W, and this is our Q. So drawing 2 is 112% of 1. With respect to 1, drawing 2 is 112% of 1. So that equals some percent times, and the drawing 1 to drawing 3 is 84%, so I'm going to put that here. So 112% going from here is equal to some percent times the whole that we got by scaling down 84% to get to 3. So I'm going to take this as a decimal, 1.12 equals P times 0.84. So then I'm going to divide both sides by 0.84. These cancel, and I get P equals 1.12 divided by 0.84. Okay. Well, if I multiply both by 100, that's going to get rid of the decimal. So 112 divided by 84 is P. And when I calculate that, 8 plus 4 is 12, so 3 will go into it. 1 plus 1 plus 2 is 5, or 4. 4, 2, 3, 4. So 3 will not go in both. So we have to find something that is the same in both. I'll just use the calculator or Siri. Hey Siri, what's 112 divided by 84?
112 12 divided by 84 is about 1.3333.
Okay, it's 1 1/3, which is 4/3. So it's 28. 28 will go into 84 3 times. 28 goes into 112 4 times. That reduces to 4/3, which is 133 1/3%. Since the scale factor is greater than 100, we just proved that it is an enlargement. The next thing says, explain how you could use the scale factors from drawing 1 to drawing 2, 112%, and from drawing 2 to drawing 3, 75%, to show that the scale factor from drawing 1 to drawing 3 is 84%. Okay. So the answer to that is the scale factor from 1 to 2. Let me bring that down so you can see it. The scale factor from drawing 1 to drawing 2 is 112%, and the scale factor from drawing 2 to drawing 3 is 75%. Therefore, I must find 75% of 112% to get from drawing 2 to drawing 3. So 75% or 0.75 times 1.12 would be 84. Or 0.84, 84%. Comparing this answer to the original problem, the resulting scale factor is indeed what was given as a scale factor from drawing 1 to drawing 3. So they're saying that since that came out to be that is the right answer. Okay, that is the end of lesson 13. Review the lesson summary and go to your problem set.